Hey everyone, and welcome back to Let's Talk About Data. Today, we're diving deep into the heart of modern cloud data warehousing, Snowflake. If you've ever wondered how a platform can be so incredibly fast, flexible, and cost-effective, stick around, because we're about to demystify its unique architecture. Whether you're a data engineer, analyst, or just curious about cloud technology, understanding Snowflake's core is key to unlocking its full potential. Let's jump in. So, what exactly is Snowflake? At its core, Snowflake is the first analytic database natively designed and built for the cloud. It's delivered as a software as a service (SaaS) solution, meaning you don't have to worry about buying, installing, configuring, or maintaining any hardware or software. Compared to traditional databases, Snowflake is generally faster, easier to use, and more flexible. Its main functionalities include data storage, data processing like loading and unloading, and analytic solutions that can be accomplished via SQL queries or supported programming languages. Snowflake operates across the major cloud providers, supporting Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP. Each Snowflake account is hosted in a single geographical region, chosen at account creation, allowing you to control where your data is stored and compute resources are provisioned. This cloud-native approach is a fundamental part of its power. Now, let's talk about what makes Snowflake truly unique: its hybrid architecture. Snowflake combines the best features of traditional shared disk and shared nothing architectures. It centrally stores data, similar to a shared disk model, but processes queries using multiple independent compute engines, much like a shared nothing system. This innovative approach is often referred to as a multi-cluster, shared data architecture. This architecture is broken down into three distinct layers. 1. Database storage layer. This is where your data lives. Data is stored in the object storage of your chosen cloud provider, AWS, Azure, or GCP. When data is loaded, it's automatically reorganized into Snowflake's internal optimized, compressed, columnar format. The internal storage components are not visible to users. Data can only be accessed by executing SQL queries. 2. Query processing layer. This is where the magic of computation happens. Snowflake processes queries using virtual warehouses, which are clusters of compute resources. We'll dive much deeper into virtual warehouses next. 3. Cloud services layer. Often called the brain of the entire operation, this layer coordinates everything. It handles critical services such as authentication, access control, security, infrastructure management, query optimization, and metadata management. All user requests, whether from the web interface or command line, go through this layer. Let's zoom in on the query processing layer and its core component. Virtual warehouses. A virtual warehouse in Snowflake is a cluster of compute resources that provides the memory, temporary storage, and CPU required to execute SQL statements and other DML operations like loading data. You can create many virtual warehouses for a single Snowflake account, and they operate independently, accessing the same shared data without affecting each other's performance. Virtual warehouses are defined by their size, which determines the amount of compute resources available. Sizes range from extra, small, 1 credit/hour, up to 6x large, 512 credits/hour, with each size consuming double the credits of the preceding one. Snowflake supports two ways to scale warehouses. 1. Scaling up, resizing. You can resize a warehouse to a larger size to handle more complex or CPU-intensive queries. New queries benefit from the larger size immediately, while existing queries remain unaffected. 2. Scaling out, multi-cluster warehouses. This involves adding more clusters to a multi-cluster warehouse to handle increasing query concurrency. You can configure a multi-cluster warehouse with either a standard, prioritizes performance, scales up quickly, or economy, prioritizes cost savings, scales up only when necessary, scaling policy. To manage costs, virtual warehouses can be suspended when not in use, and they do not consume credits in a suspended state. They can also be set to auto-resume automatically when a new query is received. Billing for virtual warehouses is on a per-second basis, with a 60-second minimum charge for newly provisioned or resumed warehouses. You can easily create virtual warehouses using either the Snowsite web interface or SQL commands. Moving back to the database storage layer, it's crucial to understand how Snowflake stores data. While you can access data via SQL, the internal data storage components are not visible to users. The key concept here is micro-partitions. When data is loaded into Snowflake, it's reorganized into these immutable, internally optimized, compressed, columnar units. Each micro-partition typically contains 50 megabytes to 500 megabytes of uncompressed data. Snowflake automatically determines the most efficient compression algorithm for each column within a micro-partition. Crucially, Snowflake stores rich metadata about micro-partitions, including the range of values for each column, distinct value counts, and other properties for optimization. This metadata allows Snowflake to perform micro-partition pruning, significantly reducing the amount of data scanned for queries. This micro-partitioning approach forms the architectural basis for powerful features like time travel, secure data sharing, and zero-copy cloning. Let's talk about time travel. This feature allows you to query historical data at any point within a defined period, or even recover dropped objects like tables, schemas, or databases. The standard data retention period for time travel is 1 day, but with the Enterprise Edition and higher, you can extend this up to 90 days. Be aware that storing historical data for time travel does incur storage costs. Beyond time travel, Snowflake offers fail-safe storage. This is a non-configurable, non-recoverable data retention period, typically 7 days, that immediately follows the time travel period. Data in failsafe is used for disaster recovery by Snowflake and is only accessible by Snowflake support. It also incurs storage costs. The query processing layer is where your SQL queries come to life. When you execute a query, the cloud services layer optimizes it and dispatches it to a virtual warehouse for execution. This layer is responsible for efficiently accessing the correct underlying micro-partition files that constitute your table. To help you understand and optimize query performance, Snowflake provides the Query Profile tool within Snowsite. It offers a graphical representation of the query execution plan, showing operations like table scans, joins, and even details on data caching, data spilling when data exceeds warehouse memory, and micro-partition pruning. This is invaluable for identifying bottlenecks. Snowflake leverages various types of caching to speed up queries. Metadata cache. Part of the cloud services layer, this cache stores metadata about your tables and micro-partitions. It's so efficient that simple queries like count, min, or max can often be answered directly from the metadata without even spinning up a virtual warehouse or scanning any table data. 2. Query. Result cache. Also in the cloud services layer, this cache stores the results of executed queries, typically for 24 hours. If an identical query is run again and the underlying data hasn't changed, Snowflake can return the results directly from this cache, significantly speeding up performance and consuming no compute credits. The cache can be renewed for up to 31 days. 3. Virtual warehouse cache. This refers to the memory and local disk, SSD, of the virtual warehouse itself. Data that is frequently accessed during query processing resides here. However, this cache is volatile and disappears once a virtual warehouse is suspended. Understanding Snowflake's consumption-based pricing model is crucial for managing costs. You primarily pay for two things: storage and compute. Let's break down compute costs. Virtual warehouse compute. This is the primary driver. You're billed for the time virtual warehouses are actively working, per second, with that 60-second minimum we discussed. Costs are measured in credits, which correspond to the warehouse size. Serverless compute. Some Snowflake features, like search optimization, continuous data loading with Snowpipe, or database replication, use Snowflake managed compute resources instead of your virtual warehouses. Snowflake automatically scales these resources, and they're also billed on a per-second basis. Cloud services compute. This layer's processing, authentication, metadata, query optimization, is generally included in your compute cost. However, if its usage exceeds 10% of your total daily compute consumption, you'll be billed for the excess. To optimize costs, consider these techniques. Warehouse sizing. Right-size your virtual warehouses to match your workload's complexity and concurrency. Running an extra-large warehouse for simple queries is inefficient. Leverage persisted query results. Encourage identical queries to use the query result cache. If your data doesn't change frequently, repeated queries can be served instantly without consuming new credits. Reduce spilling. When a query's data doesn't fit into the virtual warehouse's memory, it spills to local or remote disk, slowing performance and increasing costs. Optimizing queries or resizing the warehouse can reduce this. Reduce queuing. If queries are frequently queuing, it indicates your virtual warehouse isn't powerful enough for the concurrent workload. You can add more warehouses, scale out, convert to a multi-cluster warehouse, or increase the maximum number of clusters. Resource monitors. These are powerful tools to track and manage warehouse usage. You can set credit quotas at the account or warehouse level and configure them to send alerts or even automatically suspend a warehouse when limits are approached. We will do a live coding demo right now. Let me walk you through what a typical full-flow demo in Snowflake would look like, integrating many of the concepts we've discussed. 1. Setting up a free trial account. We'd start by showing how easy it is to sign up for a 30-day free trial at signup.snowflake.com. No payment information is required up front, making it perfect for learning and experimentation. 2. Initial setup. Then, we demonstrate creating our first virtual warehouse, perhaps named compute_WH with an extra small size, and configuring the Snowflake_sample_data database. This is typically done through a few simple SQL commands in a Snowsite worksheet. 3. Data loading. Next, we'd show how to load data. We could take a sample CSV file from our local machine, put it into a Snowflake internal stage using SnowSQL, and then use the copy into command to ingest that data into a new table. For a more advanced example, we might load semi-structured JSON data directly into a variant column, showcasing Snowflake's native capabilities for handling diverse data formats. But data transformation. Once loaded, we demonstrate transforming this raw data. This could involve writing and executing SQL queries in a Snowsight worksheet to flatten JSON data, or performing joins and aggregations to prepare data for reporting. We could even wrap these transformations in a stored procedure for reusability. Five, querying and monitoring. Finally, we'd run select queries to see our transformed data. We'd also highlight how to use the query history and query profile in Snowsight to monitor query performance, identify caching hits, and analyze execution details. This full flow provides a hands-on understanding of how Snowflake's architectural layers work together to process data efficiently. To truly master Snowflake, implementing best practices is key. Performance. Write efficient SQL queries. Utilize Explain to understand query plans and optimize operations like joins and aggregations. Leverage micro-partition pruning. Design tables with appropriate clustering keys if natural data order isn't sufficient for your query patterns. Consider search optimization service for specific high-performance lookups on large tables. Use materialized views to pre-compute and store results of common, complex queries, drastically improving performance. Cost. Right-size your virtual warehouses to the demands of your workload. Utilize auto-suspend to prevent idle warehouses from consuming credits. Monitor consumption regularly with resource monitors to stay within budget. Security. Implement role-based access control (RBAC) rigorously, granting privileges to roles and roles to users. Use multi-factor authentication (MFA) for enhanced user login security. Apply network policies to restrict access by IP address. Leverage secure views and secure user-defined functions (UDFs) to hide sensitive data and logic from unauthorized users. Data pipelines. Design pipelines to be robust, flexible, and scalable. Utilize Snowflake tasks for orchestration and scheduling of SQL statements and stored procedures. Implement streams for change, data capture, CDC, to process only new or changed data incrementally. Consider Snowpipe for continuous, near real-time data ingestion. Snowflake is incredibly versatile, fitting into many real-world use cases. Data warehousing and data lakes. Centralizing large volumes of structured and semi-structured data. Business intelligence, BI. Providing a unified platform for reporting and dashboards. Data science and machine learning, ML. With Snowpark, data scientists can build models using Python, Java, or Scala, executing code natively within Snowflake. Data sharing. Securely sharing live data with external consumers or the Snowflake marketplace. Data engineering. Building sophisticated data pipelines for extraction, transformation, and loading, ETL/ELT. Wow, that was a whirlwind tour of Snowflake's architecture. We covered its hybrid model, the 3 distinct layers, storage, query processing, and cloud services, and delved into the intricacies of virtual warehouses, micro-partitions, caching, and cost optimization. Snowflake's design truly empowers organizations to manage, process, and analyze data with unparalleled flexibility and efficiency. If you're eager to continue your Snowflake journey, here are some excellent next steps. Sign up for a 30-day free trial if you haven't already. Hands-on experience is invaluable. Explore the official Snowflake documentation. It's a fantastic, constantly updated resource. Join the Snowflake community to ask questions and connect with other users. Consider pursuing the SnowPro Core certification to validate your foundational knowledge. This deep dive has covered many core topics. Thanks for watching, and I'll see you in the next one.